This last section is volumes by disks and washers. What do we mean by that? Remember in 6.1, we were finding, calculating the integral, the area under curves, right? Or the area in between two on the Cartesian coordinate system. Now what we're looking at is volume. How does that differ? Well, volume is usually like some kind of three-dimensional object, right? Let's say we had a function right here like f of x equals square root of x. And we want to rotate it or find the volume in some interval. I'll say from the interval a to b around the x-axis. Now, graphically, what are we looking at, right? We'll talk about that. So square root of x does this, right? This is the square root of x. Now it says find the volume from A to B around the x-axis. So revolved around the x-axis, I should add that. I'll put that right here. When revolve around the x-axis. So let's just say right here and B is right here. And again, A and B could be anywhere along the x-axis. If I would take just this chunk of stuff from here to here and rotate it around the x-axis, well, what would it look like? Well, we'd have, right, kind of imagine this right here. You'd have kind of like, a top or something, or a bowl, if you can imagine, if we look at it like that, right? That's a bowl. This would be like a three-dimensional object right here. And these little blue lines that I'm drawing like this, they'd be like little slices, right? Little slices or discs, right? Discs or plates, right? Discs are kind of plates, right? They have no holes in them. So that's what we mean by, rotating around the x-axis. Now, what is the area if we were to examine? So these blues represent disks. What would happen if, or how would we find the area of one disk? Well, what is the area of a disk? A disk is just like a circle, right? What's the area of a circle? It's just pi r. What is r? R is the radius, right? Like r would be from here to here, for example, here to here. How do we find that amount? Well, r would be f of x in this instance, right? But since we aren't just looking at one individual disk, right? We're integrating. We're trying to find what would the area be of this entire shape from A to B if we revolve about the x-axis. But we need to find the entire area. We can't just look at the area of one little disk. We have to look at the area of all these disks summed up. But how do we do that, though? We're not going to sit there and find the area of 50 million disks or an infinite amount of disks, right? Remember, what tells you the area under a curve? Integrating, right? So the area, or the volume is equal to the integral from A to B. A to B is the x coordinates. Why is it the x coordinates? Because we're revolving around the x axis. If we were around the y axis, everything would be in terms of y. Instead, we'd be looking from here to here, right, along the y axis. But when you're doing it around the x axis, it's always with respect to x. So it's going to be from A to B of pi times f of x squared x. That's how you can find the volume of some kind of curve if you were revolving it around the x axis. Again, everything's in terms of x, right? Your limits are in terms of x. Your equation on here needs to be all x variables. Remember the previous section, sometimes when we were doing stuff with respect to y, we had to sit there and rearrange the formula, right? You're going to have to pay attention to that sometimes. So again, everything here has to be in terms of x equation, x limits right here. So we'll do a couple of these, then we'll do it on the y-axis, and we'll see how that works. It's the same concept, but everything has to be in terms of y, meaning the limits have to be in terms of y, your equation has to be in terms of y. This would have to be dy right here. All right, so let's find the volume. When rotated about the axis. Now let's try this equation. Y equals 2 minus x, or the square root of that. And then from -4 to 2. So you may be asking, how do I know do I have to rotate about the x-axis or the y-axis? They're going to specify, okay? Like they're never going to say just find the volume and then give you the function. And they have to give you points, some kind of region, and they have to tell you what this is. If whenever they give you the points, it's with respect to what initial axis they're telling you to rotate about. So this is in terms of x right here. So what does this look like anyway if we were to graph this right here? We're just going to draw a nice little rough little sketch because it's important to know what this stuff looks like. So what does the square root of 2 minus x look like? Remember that negative in front of the x means it reflects over the y, so shooting off to the left. This is a horizontal transformation. So 2 minus x looks something like this right here. And we want to rotate about the x-axis from -4 to 2. Remember, this is with respect to x. So -4, we'll just say it's about here. And this is +2. Really, we don't need this arrowhead anymore because we're just solely focused on this from here to here, right? Now, if we take that and we rotate about the x-axis, what are we going to get? We're going to get a top again, right? Like you take this and rotate it, you get a nice little sideways top. And then we have our little slices, right? Our little slices that we're looking at. Now, how are we going to find this volume? We're going to apply that formula, that initial volume formula. We have volume equals the integral from a to b of pi, and then f of x squared dx. So remember, all this stuff has to be in terms of x, y, because we're rotating about the x-axis. So far, so good. So we can say the volume is equal to, and your limits have to be in terms of x in this case. So from -4 to 2 of pi, and then your function square root of 2 minus x squared dx. Don't forget, you must always square that function. A lot of people forget the squared right there. Now we need to integrate this. Well, what's the square root of something squared? They knock each other out, right? So now we have the volume from -4 to 2 of pi, and then times 2 minus x dx. So now it just got a lot easier because we were able to eliminate the root. So that pi we can move out in the front, right? That doesn't do anything. It's, well, it will, but it's just a constant. If we integrate 2 minus x, you get 2x minus 1 x squared. And then we're going to evaluate it from 2 to -4. That's just upper limit, bottom limit. So we have 2 times 2 minus a half, 2 squared. That's our upper limit minus the entire bottom limit. Watch the signs right here, right? 2 times -4 minus a half, -4 squared. And we're going to multiply pi into that at the very end. So watch the arithmetic, right? This is 4. This is 4 times a half, 2. So we have that minus, this is -8. This is positive 16 times a negative half is -8. So you get 2. This is -16 plus 16. So you get 18 pi. Do not convert this to decimal. Leave it in exact form. All right. So basically what this says is if we were to rotate that square root of 2 minus x from x equals -4 to 2 around the x-axis, that top or that volume amount would be 18 pi right there. Usually the integrals aren't difficult to set up at all. Probably the biggest issue is, again, people forget to square the function. All right. And then other trouble spots is they will mess up with the arithmetic right here. Watch the signs. Take your time. Don't forget the order of operations. All right, let's try another function. Let's say we have y equals x squared plus 2. And then again, we're rotating about the x-axis. So find the volume when revolved around x-axis. Okay, so again, let's just draw a rough sketch. What does x squared plus 2 look like? Well, it's basically, it's a u-shaped function, right? It's a parabola that's been shifted up 2, and it looks something like this, right? That's what x squared plus 2 looks like. And it says from -1 to 3. So I'll just say, oh, -1 is about here, 3 is right here, right? Just, it really doesn't matter. Just to draw a rough sketch. I'm going to eliminate this part right here. Well, this isn't, I'll put -1 a little closer. There we go. So if you were to rotate this one, it'll look kind of weird, right? I'm going to do my best to draw a 3D picture. Ooh. So it looks something weird. Kind of like that, right? That's what it's going to look like if you can imagine it, right? Usually way easier to rotate it in your head than draw it out. So kind of like a megaphone type thing. But again, we're being asked to find the volume if we were to rotate this particular curve from x equals -1 to 3 about the x-axis. So what would your volume be? It's the integral from -1 to 3 of f of x pi times f of x squared dx. So you're going to have x squared plus 2 squared dx. Remember, volume is the integral from a to b of pi times f of x squared dx. That's where this is coming from. Again, f of x squared is just your function squared right here. So now, where do we go from here? Well, we got to take this squared, right? We need to FOIL this out. FOIL this. Why? Because you have two terms that you're squaring right here. So if you FOIL it, it's not just going to be x to the 4th plus 4, right? You have an outer and an inner term. So we still have the pi, but the constant I'm just going to throw out in front of the integral. If we FOIL this out, we get x to the 4th plus 4x squared plus 2x, right? We still have the dx, I'm sorry, plus 4. Now we can go out there and figure out what the antiderivative is. So this is 1/5 x to the 5th plus 4/3 x cubed plus 4x evaluated from 3 to -1. And again, we just take our time, right? Plugging these values in. So we're gonna, the upper limit, 1/5 times 3 to the 5th plus 4/3, 3 cubed, plus 4 times 3, minus the bottom limit, 1/5, negative 1 to the 5th, plus 4/3, negative 1 cubed, plus 4 times negative 1. And then you multiply pi into it in the end. So what do we get when we compute all this stuff? So after you type it all into your calculator, right? Watch the signs. You will sometimes get big nasty numbers, and you wind up with 2996 over 45, just like that. So again, just take your time plugging it in. Remember to plug in fractions, right? Use this ABC button right here, right? That's how you put fractions into your calculator. Now, what about rotating about the y-axis? How does that change? Well, like I said before, it's pretty much the same concept, except that now we have everything in terms of y. So again, conceptually, what if we had, say, the y equals the square root of x, and we were going to revolve around the y-axis from the interval CD. So if you notice, I changed the interval, right? For the x's, it was a and b. For the y's, it's c and d. What would that look like? Well, the square root of x still does this. Or I'm going to exaggerate it a little more, something like that. But let's just say that this was, c, and d was up here someplace. And of course, is the y-axis, right? If I were to take this particular shape, square root of x, and rotate it around the y, well, you're still going to get a top, right? It's just going to be opening upwards. Instead of to the right or to the left. And you'll still have these discs, right? We're still going to have these discs right here. These little itty bitty discs. Now, for the volume about the y-axis, it's still the same concept. What if we wanted to find the volume of one disk? Well, the volume of one disk, it's still pi r squared, right? Or one circle, but we want to find, if we need to find the volume of an infinite amount of disks, well, we would use the interval. So it's going to be the integral from c to d. Why? Because we're dealing with y now. Think in terms of y, of still pi. And then you're going to have f of y squared dy. So notice now everything's in terms of the equation in terms of y, the limits are in terms of y, so you need to pay attention to that right there. Give a couple of these a So here we go. We have a root function again. And this time we want to find the volume when it's rotated about the y-axis from y equals 2 to y equals 4. So this time I'm not going to be putting points down here because we're not going to put 2 and 4 along here. That would be for x. We're not dealing with x. They said y equals 2 and y equals 4. So that's about right here and here. So this is what we're looking at, right? This chunk right here. And of course, if we were to rotate that, you would get that top like what we had before. And again, we'd have our little slices, right? Just like that. So remember, the volume, when rotated about the y-axis, is from c to d of pi f of y squared dy. So we have our limits in terms of y. We're good, right? We know that it's from 2 to 4. But f of y, we don't have our equation in terms of y. Remember, when we say in terms of y, it has to be x equals blah, blah, blah. This is not x equals blah, 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 right? Y, I'll put that down here. Y equals square root of x is not in terms of x. So we need to isolate x. So how do we do that? If we start with y equals the square root of x, how do we get x by itself? Well, you have to undo the square root. What's the undoing of a square root? That is squaring both sides. So now we have y squared equals x. So that's what we mean by in terms of x, correct? Or in terms of a specific, you need to solve for that specific letter to the first power. Like we had to get x equals, like say in terms of z, example, you better make sure your equation is z to the first equals blah, 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 everything else. So just like right here, we now know that f of y is equal to y squared. Now we can successfully fill in our integral. So we have the volume from 2 to 4 of pi, and then we're going to have y squared in here, squared dy. That's probably the problematic spot. Again, it's not taking the antiderivative, it's making sure, oh, did I isolate my equation correctly? So again, when they say isolate in terms of x, it has to be x to the first power equals everything else. Or if they say isolate in terms of y, it has to be y to the first equals everything else. Or isolate in terms of z, it has to be z to the first equals whatever. And I keep mentioning z because for those of you who are going to continue, taking more math courses like multivariable calculus, you'll have double and triple integrals. So you'll x dy z, and that's going to pop up a lot. But continuing with this, we got to take care of that squared out. So we have the volume equals the limit from 2 to 4 of y, and then this is y to the 4th dy. And then we have, when we take the antiderivative, that's just 1/5 y to the 5th evaluated from 4 to 2. And plug all this stuff in. This is the upper limit minus the bottom limit. And again, we'll use the fraction button on the calculator. So we're going to have pi, and this is 1024 over 5 minus 32/5. And then we can type that into the calculator, right? You would say 1024 ABC 5 minus 32 ABC 5. And we get a mixed number, right? Remember, to convert from a mixed to an improper, you keep it there and you press second, the ABC button, and we get this big number 992 over 5, and then don't forget pi right there. All right, so let's try another one. If we have, say, y equals x cubed. And again, we're rotating, we want to find the volume when we rotate about the y-axis. From, we'll say y equals 1 to y equals 8. So what is that? Let's draw a rough sketch, right? On the homework, it'll ask you to draw rough sketches and you have to choose, from some multiple choice thing. So y equals x cubed looks something like this right here. And then y equals 1 to y equals 8. Remember, y-axis, right? This is the y-axis, the x. So from 1 to 8, it's about here and here. So we really don't need the rest of this shape, right? So I'm just gonna eliminate it. So you want that little chunk, right? And if you take that little chunk and we rotate it, you get kind of like a cup type thing, right? We have our cup, and then again, you have your little slices, right? Nice little slices right here. Now, again, remember the volume when rotating about the y-axis is the integral from c to d of pi times f of y squared. We have our limit, right? They said, oh, from 1 to 8, that's y equals 1, y equals 8, right? So we're good right there. Do we have f of y, though? Is our equation 100% in terms of x? No, right? We need to go out there and isolate this thing. We need to isolate x. So if we have y, basically we're looking for this f of y equals question mark, right? That's what we're looking for. So if we have y equals x cubed, again, to get in terms of x, we need to isolate x. X is not by itself. It still has a cubed right here. How do we get rid of the cube? Or opposite of cubing something, or what undoes a cubing something? Cube rooting, right? This right here. So we need to take the cube of both sides. Now, when you do that, though, we get the cube root of x cubed is x equals the cube root of y. Remember, whenever you derive or you anti-derive, you want to write radicals in exponential form. So this is y to the 1/3 power right here. So that's what we're going to put, right? That's our f of y in this instance. It's y to the 1/3. So our volume in this instance is from 1 to 8. Now I'm going to put that pi out in the front. You could leave it right here. It doesn't matter. In the end, we're not multiplying it in the decimal, right? It floats at the end of the answer anyway. So we have pi, and then the integral from 1 to 8 of y to 1/3 squared dy. Don't forget the squared, right? That's the two things that people forget with these, the squared and isolating. Remember, when we say isolate in terms of x, it has to be x to the first equals everything else. So we had to get rid of that cube. That to get rid of a cube, you do the undoing of it, which is the cube root. So if we continue along, we have the volume equals pi from 1 to 8 of what's y to the 1/3 squared. Remember, exponent raised to exponent, you multiply, so we get y to the 2/3 dy. When you take the antiderivative, remember it's y to the n plus 1 over n plus 1. That's y to the 5/3 over 5/3, but that's the same thing as multiplying times 3/5. And we evaluate from 8 to 1. So you have the upper limit minus the bottom limit. This you can plug into your calculator again, or you could simplify it without it. Why? Because 8 to the 5/3 is the same thing as the cubed root of 8 raised to the 5th power, right? Remember this, if we convert it to radical form, it's the cubed root of 8 to the 5th power. So that's 2 to the 5th, which is 32 right there. So we have pi and 3/5 times 32 minus, well, 1 of the 5/3 is 1 times 3/5 is 3/5, right? So then we have pi, and this is 96 over 5 minus 3/5. So then you get 93 over 5 pi, and there is your area right there. But again, biggest thing that people forget is the squaring of the volume. Doesn't matter if you're doing volume around the x-axis or the y-axis, you must square your function and multiplying the pi through in the end. And the other big thing is making sure your function is correctly in terms of that specific variable. If it says rotate about the x-axis, remember you have to have y to the first equals everything else. If it says rotate about the y-axis, you have to have it such as x to the first equals everything else. And again, it will always specify that for you, whether or not it wants you to rotate about the x or the y axis. So I'm going to stop right here. Now this will be the part 1. The second part are washers, which is what happens if you have 2 different functions, right? And you're rotating them, because if you have that, you're not going to have a disk. Remember, a disk basically has no empty space, right? Discs are like plates, just a plate that you eat off of. But a washer, remember, if y'all have ever been to a hardware store, washers are like discs, but they have holes in them. And those come about whenever you're rotating between 2 different curves. That will give you a hole in the middle. So we'll look at that for the second part of this section.